Hey, hello, this is David D. Hilster. I am a critical thinker, dissident scientist, and today I am doing my live chat like I do most every Friday. And today I'm going to be talking about debating mainstream science. There was a guy, I got some comments in my last video from a person who says, you should debate somebody in the mainstream. And I said, well, I gave them three reasons why that wouldn't happen. And it turns out that he says, well, I'm in the mainstream. So it got me thinking, and I'd mentioned to him, and I mean, I've thought a lot about it, but I sort of went on and debated a little bit, a couple of comments, and he wanted to, I think, talk about the math where I was going wrong, perhaps on the math with relativity. And of course, I'm a mathematician. I've been looking at relativity since the early 1990s, well over 25 years. And of course, I'm a student of Dr. Karazani's and study his work very carefully. And I pointed to him, I said, look at autodynamics.org and take a look at that. Again, this is no cut to him. I think he subscribes to me, or well, if he doesn't, at least he was there, and he was pretty polite about it. But I just, I'm going to talk a little bit about that today. But debating or talking with people in the mainstream, even like this guy, he already has going in. He's going to show me where I'm getting the math wrong. It's the idea that, in my opinion, at least, that this person's going to come and save me from myself because I don't know, the math, or I don't really understand it. And so instead of going to, I don't know, maybe he will, or she will go to autodynamics.org and take a look at Karazani's problems he found in special relativity, both mathematical and conceptual, that maybe he or she will actually look at it and make some comments. Of course, I also have a video out that someone said, I found this. I was talking about Karazani. I did a video on Karazani's work showing special relativity, the problems he found. And someone says, look, oh, wait, are you talking about Karazani's been debunked? And I said, well, how's he been debunked? And they pointed me to an article. So if you do look up Dissident Science Karazani, Karazani, put that in here. Hey, hi, how's it going, everybody? Appreciate you guys coming by. Karazani, Ricardo Karazani. I did go through the article where they say they debunked Karazani, and boy, it was not very good. Those people, to give you an idea, and I gotta find this. I have it somewhere. I actually have the letter itself. There was a letter that maybe I'm going to look on the internet. Maybe I have that in a file that I can show you. But Karazani's work in the 1993 or 94, I took his work and gave it to 9 physicists at Space Park, where I worked. I worked at TRW at the time in their artificial intelligence group, and I wrote the president, I remember his name, Gorman of TRW, says, hey, I've got an experiment you can do that could win a Nobel Prize. That's what I said, because you would show special relativity wrong. And so I found myself 3 weeks later inside a room with 9 physicists. And it was a small room. I remember that. It was like, I felt, and I went in there, and there were just all these people sort of, and then they started quizzing me about what I had. I had a bunch of copies of Karazani's work, and they were asking me what it's about, and I said special relativity. What's the experiment about? Well, it has to do with decay rates, radioactivity, and measuring that and showing that, in fact, again, he has a new radium. It's called New Radium E experiment. Go to autodynamics.org. And then they said, well, what are the implications? And I said to him, well, the implications are that one of them is there no neutrino. And one guy says to me, or turns to another guy, says, wait a minute, I thought SN supernova 1987A proved that there were neutrinos. For those who you don't know that, 1987 is when the supernova exploded. It was one of the rare times where we saw a supernova explosion and recorded it. And then when we saw that, there were supposedly neutrino detectors around the world that detected the supernova, and therefore gave no doubt that, hey, the neutrinos detector detected neutrinos, therefore they do exist. And the guy said, well, oh, just so happens that this piece of paper, this is it, this piece of paper right here, which was something I already had ready from Karazani. I had a bunch of his work, so I'll show you about 7 reasons why it wasn't evidence for the neutrino being detected. And I asked him right at that point, I said, oh, so you're a neutrino scientist, so you know all about this? He goes, no. I go, well, then how do you know that they detected neutrinos? He says, well, I trust my colleagues. Whoa. I remember that. Oh, I remember like it was yesterday. It wasn't. It was, it's over 20 years ago, almost 25 years ago. 25 years ago it was. And so I said, okay. And then they asked the big question. This was also really interesting. They said, so are you you're a physicist, right? And I go, no. And then all of a sudden they just looked at me, laughed at me. And he says, well, Dr. Karazani says, yes, he has a PhD in physics. He even did an experiment at the Stanford Linear Accelerator. So, but I'm a student of his. Okay. Oh, and then they just took all the papers out of my hand, and they said, okay, you can leave now. I go, well, you don't want to ask me a question? No, I don't see any reason. No. So anyways, they then took all the papers and shoved me out of the room, and then I didn't hear anything for weeks. But I did hear back from them in a number of weeks later, and I got a letter from them, and I'm going to see, I don't know if I have, I'm going to see if I can find that. In fact, I may have the actual letter. So hold on a second. I just thought of that. Let me be right back. Be right back, folks. Yes, sir. I will be right back. I'm coming back. I'm sorry. People are going to come here like, where is he? Well, I have it in my I have a fireproof safe here. And it's in a folder from safe. I think it's good for 2 hours. I don't know how much. I'll probably. Anyways, all this stuff here. Well, I should just go through this and throw tons of this stuff away. Things that we think we can't lose. Come on. What am I looking for? You're wondering, why is David going through his firebox? It's because I supposedly have a letter from TRW in here. I certainly hope so. If not, I thought I had a copy of it electronically. But nope. It is a letter that I can tell you about if I can't find it. Alrighty. Where'd you go? I'm going to look one more time here. These. It's a TRW letter on their letterhead. It's in an envelope. I know exactly what it looks like. I hope I didn't lose it. That would be terrible. I don't want to lose people on my... Wait a minute. Okay. it isn't here, and that's not a good thing, because I need to have that. So one more check through. All right, I don't have it, folks. I'm going to check if I have an electronic copy of it at least. I did take a picture of it and make it available on the internet. Now I don't know, because I don't, well, I think it's there, but I don't show it. Well, great, it ain't here, and that is no good at all. It's probably somewhere else then. Of course, if it ain't here, it's somewhere else. So I will tell you what's in it, that letter. And basically what was in it was pretty shocking, actually. It was shocking in a good way. I wasn't surprised, but they didn't do the experiment in the end. And I think I may know where that is. Now I'm going to find it. And they they said the first thing out of their mouth, basically, said, after looking at his work, we couldn't find a problem with it. We couldn't find any, basically, errors. In fact, it said it looked like it would, how do you say, not simplify, but I don't remember the exact words. But basically, I was real shocked. We couldn't find anything wrong with this guy's argument. And then after that, they said, well, two things after that, and I go, oh my gosh, you're going to do it. And then they said, no, we're not going to do it for two reasons. One, it involves radiation. And I thought to myself, okay, you guys made the lunar lander engine, the ascent engine for the lunar lander, and they have all kinds of radiation tests, and they can't do that. So I figured that was not really the truth. The second thing what they said is we don't perform experiments just for academic reasons or to prove some point. But it was really at that point after, and I had known Karazani only for a couple of years, and I was going through his stuff, I didn't really have an explanation that I can explain it to you guys now easily. I didn't come up with that for many years until many years later. But in general, I was, at that point, was the thing that really propelled me into where one of the reasons I'm here today is because I said, oh my gosh, this guy, what if he was older? I met him when he was already in his 70s. He's pushing 100 now. I don't know if he's even still alive. We don't talk anymore. But I thought to myself, my gosh, I've got to really help this guy. I've got to look into this. This is real stuff. I mean, they couldn't find any real problems with it. So I figured to myself, okay, let's go forward with this. So that's what I did. And, so I'm trying to find it, even an electronic copy. Now I'm going to, next time I'm around, I'll do it. But I wanted to show you guys that. But that was pretty amazing. It was a 2-page letter, and it is somewhere. I'm not going to look for it anymore. But anyways, hope all is well. And Pyro, did I see this as the best way to contact you for a hangout? Didn't see anything in Science Woke or Center pages. Oh, yeah, you can. I can contact you. Yeah, you were writing. You were wanting for us to, have a chat. Absolutely. Contact me at, this is public anyway, so you can contact me at this, and I can send you give me your email, and well, I've got lots of emails. Let's put it this way. I'm putting it as David, so I'll put my David D. Hilster email, which is also sort of public anyways. And you can send me an email, and I'll be happy for us to set up a time. An interview. I like to interview people too. It's not easy to do all the time because my computer's getting old now. It's like 5 years old, but that's old, and computer ain't time. And you have to have Skype running and OBS running and all that stuff. I've done it. Worked out nice. Some of the interviews that you can see. I think I have a playlist called Interviews. Did one with Stephen Hurl, Greg Volk. I did a couple with. Did one with Glenn Borkert. But this one would be on someone else's channel. That would be wonderful. If you're familiar with hysteresis, what does your model make of it? I'm not really familiar with that. Universe hack. Well, the good news is, yeah, it's going to be. We're looking to have it come out this year. Let me tell you why our book is delayed. It's just taken a long time for us to come up with a way to communicate it. Like I said, I've got, how many versions of the book already? My goodness. Yeah, there's 2 of them right here. Universe Hack 3, and you can see the title's changed already. No math physical model of the entire universe, the math particle model of the entire universe. You can see even this one here says review copy. Yeah, you can make books so cheap now. This one's in black and white though. My goodness, this has got like almost 300 pages. But yeah, we plan to come out. We're looking to. I'm gonna, go much more full bore on it. I also came up with a really great explanation of how to sort of characterize what this model is, and that just literally just came to me about a month ago. So we're looking now to write the intro again, get to it's going to take some time. I mean, but our plan is to have it done this year. My dad's getting old. I want to get it out, so we're going to put the pedal to the metal and put it down. And I think it's going to be a lot shorter. We have a lot of information. I've made a lot of diagrams. Ooh, they're really cool. I mean, most of the graphics I've done myself, So really fun stuff. Let's see, I'll give you some graphic. That's pretty cool. Oh, here's on polarity of atoms with movement. It talks about our model and how atoms and molecules stick together. And here's the double slit with detector. We actually have an explanation for that. It's all particles. Oh, and this one is wrong. But this is one of the best explanations we have. It's the refraction and dispersion. Why does white light turn into a rainbow? Dad talks about the right hand speed of gravity. Whoa, this is pretty cool. My dad's also working on stuff for even's got things about color. We were really into color and why color exists and all that. Of course, I have the Yonel-Deneau effect. Look at all these nice stuff. Fun. Anyways, I'm just rambling on here. That's pretty cool. Man, we should go back to that. We should get this book out, huh? You can't see it, but those are, you can see sort of this oval with like stuff in it, and each one of those are just bunches of particles, and that's what we say light is. We don't say it's in a medium or something, but whoa. Huh. It's funny here. I'm sorry, I'm not talking. I'm sitting there. You can see my notes in it. And then I had some, a couple friends. One of my friends go through it. Who was like, "This was a really cool one." This is the Deneau effect, and all of those are little. You can't see them because this is like high resolution. But if you look at it, I actually wrote an HTML5 program to make all those little dots that are random that go around in a circle, and they have little lines after them. That's how we use motion for particles. Here's how particles look like in a wave. See, they're just coming to you, and the wave part is just crutch. See, that's what light is. That's all light is. Particles and waves, all flying together in our model. Is it right? Could be all wrong. How many people say that about their own model? Nobody, huh? Oh. Oh, man. Dr. Cattersani's going here. I'm not surprised. It's the first time I ever heard anybody say that. I would have been there if I would have known, even though we weren't talking. I thought it doesn't have it in the Wikipedia. He's in Wikipedia. I mean the Wikipedia. I'm sorry, guys. Dr. Cattersani is a special person to me, even though he wasn't in my movie. Let me see. I'll take a look at it. Kevin Kane about. Yeah, I'm not surprised. He would have been 97. He was on a strict diet, though. Is the CMPS going to publish the Universe Hack book? We publish stuff in the sense of we put it as the publisher. We will publish, any of our members' books. We're not here. The idea of the CMPS isn't to endorse anybody. It's to support everybody we can. And obviously the work has to be scholarly. Doesn't mean that, we have, no one's going to agree with everything that's in it. But if Cattersani's gone, yeah, they don't have, at least they don't have his date here. I tried to search for it too. I'll show you where I'm at. Well, anyways, I'd like somebody, if they know about that, let me know for sure. So Tyler, if you do know when he passed away, then he was at my 50th birthday party. I'm 60 this year coming up. So, oh. Message retracted. Yeah, I noticed on Wikipedia hadn't updated about it as well. Yeah, I know that I think they, I actually think this is an interesting story for you when we talk about mainstream science. I remember he created a polemic because he, I don't know why they don't have his picture in there. I'll take a look at the picture we have, but he created a polemic, Cattersani, because he actually took out his daughter, who's a doctor. She's not rich, but she's not poor either. She took out a one-page ad in the New York Times or something like that. I mean, that big, and it cost a lot of money. And she printed his work in it, and that created actually a little bit of tumult for a little while. And they were saying, what is they were not debating as much as Cattersani's work as why they are allowing people to advertise something like that. But I thought, that was pretty amazing. I can probably try to find that. I should put this all on his website. But here's a picture of Dr. Cattersani, and for those of you who don't know the story. This picture was taken by, hey Lisa, this picture was taken by, gosh darn it, what's his name? He died a while back, and actually I was still talking with Cattersani at that time. Herman Leonard. Let me go and find Herman Leonard. Oh, that's not going to be in our database. Who is Herman Leonard? He is a super famous, yeah, he died at 87. He's a super famous, Paris. Isn't he a photographer? Yeah, he is a photographer. Okay. Herman Leonard. I'll go to his website. His Wikipedia didn't say much. Just a super famous guy. This is one of his pictures of Miles Davis. Herman Leonard's works were acquired by the Smithsonian Institute, and he has some. Look at who he took pictures of. Billie Holiday. He took one of the most iconic pictures of all of in jazz. Let's see if I can find that. It was of Duke Ellington, I believe, sitting at the piano. And this is the same guy who took this picture. And guess who arranged that? Me. That's pretty cool. I'm not trying to toot my own horn. Believe me, it's. Let's see if I can. But I mean, he did jazz greats. All these people. I mean, he was just. He loved jazz, and he hung out with these people, and they let him get close. Billy Eckstein, yeah. All these are a few all jazz. Yeah, he did. Miles Davis was one of the. That's one of the really great photos. I don't know if he has something like I can search on, but anyways. Oh, here we go. Louis Armstrong. There he is. Let's see if we can see. Where's the one at the piano? There's one of them. Paris. Something like that. I think that may be it, but it looks like it's in backwards. Anyways, I'm probably no. Anyways, I arranged it. Well, it turns out that he took Carazani's picture. I don't think these are all jazz celebrities, fashion New Orleans celebrities. Fashion New Orleans, pop rock, new images. Well, he's gone now. Herman Leonard. Anyways, took pictures of himself. Actually, I have pictures. That's him. I remember that's what he looked like when I met him. It was an incredible shoot. I got to be at the shoot with him and watch him work with Carazani, and he took numbers of pictures. And I do have those pictures of Carazani that he took. Quite nice ones. I think I can find those for you. But the whole story of it is, I said, hey, you want to take a picture of one of the famous scientists of the world, and got him his picture taken. And of course, in my opinion, his work is going to be a sort of sentinel work that helps shift us in our understanding what relativity equations were, where they made the real mistakes were found, and why, and generating a new set of equations that actually can be used with that don't have the magical power in it, and that's what he sort of did. So, anyways, that's pretty interesting. But I certainly would like to know about that. Have you heard about the hollow Earth theory? Kevin kindly sent me a free copy of his first autodynamics book. I already had his Storm in Physics book. Yep. Here we go. Since we're on that still. This in here. To David D. Hilster, Long Beach, California, 30th of March, 1999. Wow. I used to think 1999 was forever in the future. But it's pretty nice. The SAS, the Society for the Advancement of Autodynamics. I wrote an intro to it. Very interesting. Is not inside tensor equations. Yeah, I don't know if it's interesting to read to anybody. But I'm in there as the SAA president. We had 3 or 4 members is all. But I wrote an introduction to it. And then pretty much what he has in here, the derivations in this book can be found on the internet, on the website. I think some of this most seminal work is the Bohr's atom, where he actually derives the Bohr's atom equations. We demonstrating started with the and he derives the Bohr's atoms without any relativity at all, or the neutrino. And so this is the Dirac equation. So he literally, with the autodynamic equations, that is the corrected special relativity. Basically, for those who don't know and sort of more layman, I'm just off on this tangent here, but that's okay. This is where some people are talking about it. But basically, I'll talk about the hollow earth. I will talk about that. Basically, what Karazani said was the universe. The problem with special relativity is that everything that's moving has its own frame of reference. Now, frames of reference, first of all, are mathematical constructs. They ain't real. You can't find a frame of reference anywhere. In fact, if you take any object anytime, where's the frame of reference on this? Well, you can try to maybe find the middle, but it's made of smaller things. So if I got super small, smaller than an atom, this would be mostly space. So, having everything, so does that mean where do you put the frame of reference? Is it on this one object? Is it on every atom? Is it on every subatomic particle, the electrons and the neutrons? If you believe in quarks, which most of us don't, but where do you put a frame of reference on everything? And every frame of reference then creates its own little world, and then within that frame of reference, everybody would have to see the speed of light the same speed, and that's where you get into all this problem of the twins. And if you go close to the speed of light, the time slows down, and he ages less, and mass increases, and all this stuff. Well, Karazani said basically the problem is you can't have 2 frames. They reduce down to 1. That is, when you do mathematical equations for deriving special relativity equations, those ones with the crazy things like as you get closer to the speed of light, time slows down. Well, it all collapses down into one frame. That mathematically you can show it's redundant, and if you go to the website and you're into math, it's just basic algebra, you can see it. Basically, when you have 2 frames, what he's saying is that here's a frame. I'm going to pick a point of reference here, and if there's an event going on, there's an event going on. And depending on where you can move the one point of reference, but there aren't 2, and they don't have any relationship. There's an event happening in the universe, and it turns out that Einstein wants to make this sort of observer concentric. So Einstein says that the speed of light has to be measured. So if the speed of light's like this, and I'm moving compared to you and I are going to have to still measure c, which means my world and my frame has to slow down and yours has to stay the same, or vice versa. And it's just nuts. When any physics teacher teaches this in physics class, I would say probably 80 to 90% of all the students are scratching their head. Why would this happen? And they're never given anything other than, it's because Einstein said so. Anyways, let me go here. I'm going to find Karazani's photos if I can. But anyways, Karazani came along and said there's only one frame, and you can move the point of origin around. That's all you can do. There aren't 2 frames, and if you can't have 2 frames, if there are no physical reason to have 2 frames, the only reason you have a point of origin is you're going to measure something, but you can't have 2 and they don't physically represent anything. There's only one frame. There's only one 3-dimensional space. We live in it. It's not 4 dimensions, not 5, it's not 17, it's not 29. It's one 3-dimensional space. And all we can do is move the origin if we want to do calculations and have that relationship to the event. So you never have this problem. Whether you're moving or not, it doesn't matter. And so he did that, he simplified it, and it turns out what his equation says, for this to move in a static system, meaning this is all you have, for this to move, and he says, people criticize him, of course your equations are wrong, Karazani, because what you say is as the speed increases, mass decreases. You just change it. No, what he's saying is to move this on its own, without any external force on it, it's got to lose mass. This is a rocket. It's sitting on the ground. There we go. It's a rocket. We're not going to put anything from the outside. We're not shooting lasers to make it go up. We're not squirting air at or water at it. It's going to go up on its own. How does it do it? It pushes out mass to move itself. That's all Karazani said. And those equations came from his finding the 2-frame problem, reducing it to 1 frame, and coming up with a set of equations. So that's what he did. And what could he do with that? Well, he could describe collisions in the atom smashers without the neutrino. And that's one of the other things he found, is that the neutrino was introduced because they applied special relativity, and they have all this thing. Oh, well, the electron's going at 0.86 the speed of light. If it's going 0.86 the speed of light, there's got to be more energy or more mass there than we see, because special relativity says that. Pauli, one of the great scientists in the 1930s, he died, I think, early 1930s, he said, well, folks, if you believe in special relativity, you got to apply it to radioactivity, which is just sitting here and there's energy coming out by itself, or mass coming out, we would say. Therefore, if it is, then you have to calculate it, and we should see extra energy coming out. We don't see it. We can't detect it. Everything all the heat that's coming out, and we can do calculations with this radioactive material. Guess what? Chemistry and physics said all the stuff there where we predict is coming out, we measure it, it's 100%. But Pauli says, no. If you like Einstein, if you worship Einstein, you got to apply that. And so what they do? They invented a particle. Well, it can't have charge, because they would see some type of charge coming out. Oh, it can't have mass, because they'd see some kind of mass going out. So what did they invent? The neutrino. Neutrino meaning, they were going to call it the neutron, but that was taken a couple years before that. So they called it the neutrino, and it had no mass and no charge. It basically was a ghost to take away special relativities, special energy and mass. And so Karazani unraveled that, and you cannot find that anywhere in the literature. Why? Because when you tell neutrino people, which we have, you know what they say? The neutrino people say, yeah, that's old stuff. We didn't know what we were talking about then. You can't change the facts of where the neutrino came from. So anyways, when Karazani found the mistake, then he went back and he saw what Pauli had done. He then said, I should be able to apply this equation, this new, not special relativity equation, but the autodynamic equation. I should be able to apply it to the collision of particles in a particle accelerator, nucleus collision, which is protons. They collide, and I should be able to describe everything that goes on there without the neutrino using my equations, which is a simplification. Basically, with using special relativity, you still find everything you're supposed to find. It's just like, magic extra, magic particle invented. I talk about this in my biggest, it's almost got 10,000 views. For me, that's like 10 million for, the people who are really popular, not like nerds like me. But regardless, that's sort of what he did. And then he could then also describe how the Bohr atom was, the model of the Bohr atom, the equations for that. Also, without special relativity, he could derive those. So quite amazing man. And, I wouldn't be surprised he's not with us anymore. But I can't find any information about that. Anyways, I promised to, let's see here, photos, video chats, GIFs, just seeing if I can find any of his photos. I did have them somewhere, and I can't remember. where those went. Boy, tonight I'm just so unorganized. Anyways, autodynamics. Come on, where are those? ADM pictures. Alias. Wow, this is old stuff. I remember when the internet first came on. Ooh, wow, that's pretty interesting. When the internet first was coming out in 1992, 93, I was in research, so I saw him before it even pretty much got public. I started already transforming his works onto the internet before even people had email, so that was pretty cool. Anyways, yep, Karazani. See, have you heard of the Hollow Earth? I'm going to go back down here. I know you guys are probably studying or going on. And yes, I have heard of the Hollow Earth. Now, the only thing I can say is just from everything I've talked to with geologists like Dr. James Maxlow, talk with other geologists, because I, of course, subscribe to expansion tectonics, that the Earth's expanding. I personally, from the evidence I've seen, which is the evidence they get is to do sort of use the rumblings of the Earth itself, to use those sound waves, those waves that they detect, to see what's bouncing, what layers they have. And in his book, he has the core, according to these geologists, and again, that's only because I have read it and I have looked at it. It's either said to be a liquid or a solid, but not hollow. I'm not sure how that would be proved or not proved. I think I'd have to see real reasons for it, other than it can be, because we can't go there. I mean, of course, we can't send anything down. The furthest we've gone down is not very far at all. But I know I have it in the beginning because I looked for it a lot. There it is. But, this is in his book. And what you see here is that you have an inner core, and that inner core is usually, and don't quote me, but I think it's, iron, liquid iron, or it could be even liquid boundary inner core that's probably solid. But it seems to be hotter and hotter and hotter as you get down. If you ask me, my personal opinion, no. I don't. And I think the other thing is what I usually say to people is, look, we have bigger problems sometimes to look at. Now, whether it's hollow, none of us can necessarily really say. I mean, that would be a good one to look up and really look at it a lot more, of how, like I said, they seem to be able to get some type of indication. I'm not sure. And maybe even some calculations on using the Earth's mass itself and its relationship to the sun, and calculating those kinds of things and coming up with certain conclusions. But I would say, instead of worrying about the hollow Earth, to worry about us making sure most people eventually accept expansion tectonics as a better model. Now, what's expanding it, and whether it's hollow in the middle, I think those are more details. Let's try to get over it so that when kids are learning this, that expansion tectonics perhaps is going to be shown as a better model. I'd like to get there first. That's sort of the way I look at it. It's supported by Gauss. Are you talking about the hollow Earth? Yeah, again, it's my tendency would be to say no. Yeah, let's just say it would be hollow, I would say it's going to be filled with something, gas. I mean, at a super high pressure, because it's hard for you to think that there's, I just don't see it like hollow and being able to fly in the middle of it. I don't see that, but I mean, it is possible. I don't know. I will say, is it possible? It is possible. So, are all the planets hollow in the hollow Earth theory? Don't know. That I don't know. I, like I said, I think one of the problems we have is that if we take on too many things, we're going to find ourselves. I think we first have to understand whether or not, and believe as a community whether expansion is happening. And if we at least can get that, I mean, we should work as hard as heck on something we agree on. Now, whether it's hollow or not, we should duke it out. Come to our come to our come to the CMPS Saturday morning video conferences. You have 45 minutes to an hour to present your stuff. You're going to have people going at you for sure. We got some really bright people there, so that's no problem. But I just as whether it's electric or not, I don't know. I also get worried sometimes that if you are subscribed to the Electric Universe, that there's sort of like a bandwagon to get on something or not. And I'm not sure, if there's some people explaining that. It's always healthy to have people, arguing both sides of that. So I don't know. Do I applaud it? Absolutely. You have the right to do that? Absolutely. Do you have the right to try to convince other people? Absolutely. Do I think it's that way? I don't. But could it be that way? Yeah. Could the sun be hollow? Yeah. I don't know. I mean, I think one of the problems is we can't get there. And the second problem is we don't have a good enough model of the way the universe works at the atomic, subatomic, light and gravity. We don't have any models for that, folks. So how are we supposed to be able to say what's under or what's not? So and I see you're debating that once to back and forth. Yeah, I see. Do other CMPs acknowledge that Karazani had showed errors in works? Yeah. Most people don't pay attention. It's sort of like our particle model. We even gave books away at the 2016 or 15. I had one person, there was another person who read it, but I had one person come up and say congratulations to us. And sort of, he was an etherist, and he sort of said it in a way that's, I don't know, wasn't that complimentary, almost like, oh, okay, you can explain a lot with that. But the truth of the matter is, both Karazani and my father and I's work aren't sort of people are too stuck on ether. I think that's okay. I mean, but I think they're missing out on a lot because ether has problems. I gave a talk the last conference last year, how people are seduced by ether. And the particle model actually does better at a lot of stuff than ether does. But, they don't seem to pay much attention. And the way I look at it on my side is that we are going to put out our book. It's real easy to understand. It's even easier than ether to understand. And I have some friends at work who are computer programmers who like science. I talk about the model all the time, and they just think it's a great model. They say they can't get it out of their head because it explains too much. It's easy to understand. You don't need mathematics to understand any of it. You have to have just an intuition of how gravity works, and an intuition about and the simple Yonel-Deneuve. So the way our model says is that the universe is not all electric. There's two things going on. There's particles that flow together, and that's what we call electric. That's what makes electricity. That's what makes electromagnetic magnetic fields, and that's what a lot of electric universe people are talking about. What they are talking about in the electric universe, and according to our model, are particle flow, and they flow together, or as gravity, they flow in random directions, and that causes gravity. And it causes gravity at this level, makes plants go together. There's a G2 particle, which is way down below, that also keeps nucleons going together, that keep the particles for light, which are bunches of particles. That's another thing about the particle model. What we say, photon can never be a particle. That's something I'm going to talk about. But a photon can't be a particle. He says, that's what people say you have to have ether. They're wrong. The way light in any wave, including ether, by definition, and this is something I came up with myself in the sense of how to explain it, light, by definition, has to be plural. It's got to be more than one particle, and either the particles bash together so that the light is transmitted through like waves in a medium, or the particles have to travel together in waves. You can't make a frequency. So the particle model, what we say is there is no photon. I don't know where the idea what a photon was. I think it was, well, yeah, of course I do. It comes from Einstein and the photoelectric effect. A photon comes along and hits it. What's really happening is light is, in our models, just lots of particles coming in waves. Here's a bunch of them. Here's a bunch of them. Here's a bunch of them. Or you could even just have one of them, and separated. But we don't think it's that way. We think there are more than one. We don't think there's one electron. We think there's a lot more particles. But that's a different story. But anyways, so photons don't exist. The idea. Conceptually, it's an impossibility. You can't have a wave from one particle. You have to have more than one particle. So you can write now, check photos, polls, either way. Okay. Planets form from nebulas. I'm very drawn to electric universe theory, although I don't marry myself to any one thing. Yeah, there's no problem. If you are new and, the electric universe, the only thing I say is that you have models, what is electricity, what is electromagnetic fields, what is all of those things. I follow them, and I don't see an explanation for that. And I think today and age, the better models out there are going to tell you what light is. They're going to tell you what gravity is. They're going to tell you what magnetic fields are. They're going to tell you all those things, and they're going to tell you all that way. And I think they're going to have infinity into it all. That means they got to keep going down, and your rule's going to have to apply it at the infinite levels. Whether what those infinite levels are, that's a different story. But the electric universe, here's my take on it. It is great. I applaud them. Keep doing what you're doing. But I would say, especially you, Lisa, be careful, because the electric universe, the way I look at it, here's what I would say to you, one-on-one. I'd say the electric universe helps us look at all the places, the electrical part of the way the universe works. Now, what I think that's happened is you fall in love with something and you say, everything is that. You got to be careful, because the way I see it is that there are a lot of things that aren't explained. For instance, they're going to try to, again, they don't tell you what an electric field is, in my opinion. They don't tell you what a magnetic field is. They don't tell you what the fields are. They say they are fields. And all we say in a particle model is, yeah, there are fields. There are there's two types. You've got random, it's like the air around here. This air, when I blow it, that would be electrical. When I'm not blowing and it's just sort of sitting there, that's gravitational. That's a different behavior. So what I would say is they are very good at saying, hey, this is an electrical part of the year. This part of but we have a model that sort of is more comprehensive, in my opinion. But could they be right? Yeah, they could be right. Electric universe could be 400 years from now. Everybody's talking about everything in the electric universe is correct. It very well could be. Okay, I'm sorry, not saying anything. Hope I can make a video discussing Perry Spolter's work. Oh, yeah. Go grab her book. I'm sorry. Perry Spolter. Oh, man, she's getting up in age. I know that she was presenting at our conferences. I probably got it in my other cabinet. I should put all my books over here so I can grab them. I'm going to probably be moving this year. I'm going to miss my place. Look at this. It's got this, like, that's cool. This, like, you don't have to be smart, but you can look smart. Just a joke, folks. Let's see. Dissident Dave. There is a fellow who does YouTube vids. The channel is Deep Thought Radio. He is also an expansion type of person. I think there's something to it for certain. Oh, okay. That's interesting. All right. Deep Thoughts Radio. Okay. Well, that's cool. Does the lecture touch on a difference between dielectricity and electrical anywhere? You know, I don't. You may be asking somebody there who knows, but I'm your science therapist. Tell me what electricity is. I go nuts. I go nuts with people when they get into the minutia stuff, and I go, "What's electricity?" Oh, I don't know. I know that Lori Gardy. Love her. She is a great mind. She's in art. In fact, she's one of the people who are going to be, who's a writer for our Science Woke, which we're working on. I am working on every day. Science Woke's coming along real well. I may even show a little bit of to you. It's getting there. It's getting there. I even found another writer who wrote all these great articles for us. He's a real CMPS guy, and he studied writing. And I remember he was writing all these great articles, and I felt bad no one was reading them. Now I have a place for it. I said, "Dear Harry Ricker, please let me use all of your articles because they are so good." And he's a great writer, and he'll probably be our best writer for our stuff. So, anyways, I lost completely. But I can't talk about the minutia until someone tells me what the stuff is, because let me tell you why. And this is good for being a science therapist. It's like talking about all the things on a vehicle, but you have no idea how it runs. Well, the vehicle's got like pop-up. Does it have the pop-up mirrors, or do the mirrors does it? What's it run on? What kind of engine? I don't know. So my feeling is when people talk. The electric universe talks about really great stuff about what they see, what they expect, and the probe hits the comet, or the probe hits the asteroid. You're going to see a flash. To me, all that is a release of electrons or G1 particles coming in at you. They're being released because when you hit it, you're blowing apart, atomic structure, and in space, whatever. They can explain those kinds of things and show that that's great. They're predictions. I know they have the Sapphire project going on. More power to them. They are great at, experiments are trying to find maybe better ways for getting energy, whatever. That is great. But again, to discuss the actual theoretical part and for them, and I always go back, what's a field? And if I go, when they did have a joint conference and I stood up and I asked some of these questions, I got looks of daggers. People just treated me as if I had attacked, the very essence. There wasn't a debate going on. We in the CMPS are so used to it. We stand up there and it goes, "I think your theory's full of caca." And you go, "Okay, tell me why." You don't sit there and go, "Well, yours is worse." When I confronted and I did questions that are very common, that is real, poignant, very specific questions about stuff like, okay, the universal electric, can you describe what a physically electric field is? And is that different from a gravitational field? What is that? And whatever. And I know that they just weren't keen on that. But what I would say is the electric universe people are looking to find where the electric effect in this universe is everywhere, and try to find it, see if a lot of the explanations that we have that are something else could be that. And I think that's what it is. If you take the electric universe and saying everything is electric, you are taking a stand. And we're going to have a particle model that will say, okay, electric universe, know what an electric field is and magnetic field is? No. Hey, particle model, you have it? Yes. Know exactly what it works, what it is, know why it works. We can tell you why it works. We can give examples all over the place. We can tell you how it works in the double slit. We can tell you all. What do you want to know? And it doesn't mean we're right. Now, does do ether theories do the same thing? A lot of them do. They have a problem with gravity because it's a light-oriented thing, light-oriented. So. Ooh, people are coming and going. I showed Mother 92 the graphic thingy that was done by Neil Adams. She thought it was totally logical in terms of expansion, but she hasn't been mainstreamed, so that's good. Yeah, it's quite amazing. To me, if you want to get anybody immediately science woke as quick as you can, 2008, I remember one of the aha moments in my life was when I saw Neil Adams' videos. I just blew my mind. Because at that point, you realize you're already thinking to yourself, there's something's going on. Now, the first thing is you're thinking, oh, there's a nuclear furnace and it's expanding and the whole thing's going to explode. But then when you go on and you get into it and you find out that geologists are saying, and other people are saying, no, the mass is increasing, then you can think, how does that happen? It just opens up a really great world. So that's really cool. The universe is static. And energy moving across them. Oh, so Sol Nation, you are sort of what we call a lattice kind of thing. Yeah, a lattice, static, okay. But this energy is just differing perspectives required on the recognition is something. This is something in the entire universe. Yep, that is Sol. You were talking about a lattice, sort of like the universe is full of stuff, and who proposed the lattice theory was Bruce Nappy from MIT. I think he's from MIT. I'll tell you, I've been encountering is the flat earth jazz. I mean, there's a huge community who are otherwise logical or deep thinkers who are adamant. Lisa, are you still here? I hope you are. I don't want to burst your bubble, but I have it from an insider. It's all a joke. All those people, this is crop circles, folks. I have it from an insider. Some of the biggest people in that area have confessed to certain people that this is a giant put on. They're seeing how far they can go. And it's become a game. It's just like a game. I mean, you make a logical game and they're going to push it as far as they can. And of course, politicians like it because then they can get us fighting amongst ourselves saying, look, they're not scientists. They don't believe in science. Have you heard that? I am a progressive. I have friends that are super conservative. I love them dearly. I talk with them as scientists. I love them as scientists. They are great scientists. I don't care. They've got a different political position. That's fine. But do they don't like science because they claim that climate change isn't real, that there are some studies that are put up there that give you a different answer than the global warming, that actually, you know, the trend, if you look at it, was hotter at a time. If you look at the overall trend for 300 or 400 years, am I here to tell you that it's not? I'm here to tell you that we've got to debate everything all the time. I mean, I have friends who are progressives who are science Nazis. You don't believe in that? 99.9999999% of everybody believes in X. Boy, it's not wrong to say in science ever. Since when we can what we predict weather 5 days in advance, okay? And we're going to predict an entire planet over the next 30 years? Man, I don't know. Anyways, I'm not here to say one way or another, folks. So don't. But the flat earther people they're in a big game right now, and they're having a blast. Because they're not scientists anyway, so they're not ruining it. It's not like they're teaching physics somewhere. I mean, they're not teaching a meteorology anywhere. They're doing this because the people who did crop circles, you think they were going, hey, in local news, come out, we're going to make a crop circle. This is how we do it. And, and then there's all these people saying they're aliens and all that stuff. Well, that was part of the whole thing. Until finally, 10 years later, they come out and say, okay, this is how we did it. We had wood and a rope, and this is how easy you can do it. Just sort of smash it down in these directions, how we did it. So I'm sorry, Lisa. Don't take those for real. They're pulling your leg big time. Miles Mathis, he has a large following on the Dissident types. I think somebody asked me that before. Yeah. Someone did. Yeah. Right. I guess it says Miles must bear the double burden of being a prophet and a genius. Who's asking this question? Tyler? The only thing I would say right away is, why do people... I mean, that's the first thing that comes up in Google for Miles Matheson Robitaille or whatever, the writings. So, first of all, I'm not a big fan of prophets, because a prophet is sort of a person who comes down and gives you truths. And I think truth it doesn't really exist. All we can do is we can try to find our understanding of the universe, and hopefully collectively it gets better. But that's scary. If you want to tell me or ask me about that, that's okay. But that's okay, Lisa. I'm just saying, there's no problem. Some people feel like it's that. And the electric universe stuff. I am not made of more matter than the air molecules around me. I'm simply different, attracted to different things. Again, I just ask you, what's your physical model for stuff? I think, we get into systems and the philosophies, and a lot of times we leave. Here's what people say. Just tell me what it is. Don't give me words. Don't give me systems. Don't give me vocabulary. What is it? What is light? Tell me what it is. What is the mass made of? How does that work? So, if you have that, then great. A field is a mathematical construct with a value. It takes temperature, wind waves, and then that's all the same. Electromagnetic and gravitational fields. Same for... Well, again, it depends on your model. Gravitational fields to us are random particles in all directions. Electromagnetic fields are particles flowing together like a flow. So, whatever, that's no problem. Have you seen Climate Hysteria documentary? I've heard, yeah. I don't think I've seen it, but I am aware. You have to understand, we in the CMPS have no problem of, we should never take anything as truth. All the data that's coming in for global warming, we have to constantly monitor. We have to constantly, and we have to allow for debate. One of the things the liberals don't do, one of the things that the progressives don't do, is they don't allow debate. What we need to do is say, okay, you think it's not happening. Tell me why. And there's 1/3 of all research is bad. This is by a study that you can see my movie, EinsteinWrong.com. There was a study done, and in that study from Michigan, they got anonymously a couple thousand researchers to admit that they manipulated data to get their funding. What does that mean? 1/3 of it you can throw out. Why? Because they're just trying to support their thesis, because if they got funding to say, oh, there's a Higgs boson, then they need more funding to make a bigger one so they can get to the next ones. Oh, yeah, we found it. You think anybody who gave them the money, the politicians actually deep down in their hearts believe it? No, they're taking the guy's word for it. But So in climate and global warming, everything has to be always up for grabs, always being debated. And if things are pointing like the expansion tectonics, if everything's, most stuff is pointing from expansion tectonics, we should be using that model. If we find out that most of the data isn't pointing necessarily to a global warming, the way I put it is we are destroying the planet. We are. Us create, the farming of animals where we have, I've told you about this, feces and stuff. We're destroying forests for that. My wife's from Brazil. I lived in Brazil. Over 90% of the forest destruction is there. It's going into rainforests to get cows to graze on it. They can feed one person in 1 acre. They can feed one person using animal meat and stuff. They can feed 22 people eating plants. I mean, let's worry. I always think to myself, why are we worrying about the warming part when we're destroying the planet with all kinds of other things we're doing? Chemicals. My goodness. And they're just, biodiversity is going through down the roof. Okay, Lisa. All right, see you. I was going to talk about something. Let me see if I can get to that. This comment, because they are public, so I can show them. And this again is nothing against this guy who claims to be a mainstream scientist. I'm not here to talk bad about this person in any way. In fact, I applaud them for even coming over. My question to them, though, is, why are you wanting to talk to me? And you'll be able to see here, I think, in the discussion, why they're doing that. I'm going to slow this computer down. Let me move over here. No, I'll have to go to another one. Okay, so I'm going to go to YouTube, and I'm going to go to my channel, and I will go to talking to you because it gets very boring for people, and I will go to the comments and look at the comments. They've got a good area there, and actually just look at my channel, and I can see there the video I did on Nikola Tesla and his invisibility. And I will show you just when I actually get there. I will, of course, block this out and stop it. There, I did it. And we'll look at, well, where are the comments? Oh, is this new stuff? Well, hold on. Where are the comments? There they are. Oh, wow. Where they put it? Oh, here they are. They're way down here. Okay. When you make a window thinner so you can see it. Okay. I'm going to basically, I'm going to get to it. I don't like to show you guys until you, oh, here we go. Ooh, maybe there's more replies there. There we go. Let's take a look. Right down here. Why do you complain about no mainstream scientists talking to you and then ignore a request from a scientist from an academy to discuss problems with your claims? Okay. And I replied, 3 reasons. 1, mainstream science never offers to debate. He wants to point out my problems. There's no debate. There's no discussion. I'm not interested in that. Because anybody can just sit there and he's going to tell me. It says, 2, they want to show where we are wrong. 3rd, they never look seriously at our claims. I mean, they don't. I mean, most of the time someone's looked at Karazani's stuff, or most of the time they've come and criticized something about me, clearly didn't understand what we were saying. I said, here's the way I look at it. Explain what Karazani said about special relativity. Explain to me about how he showed that the Lorentz equations, in fact, can't generate, you can't generate the Lorentz equations using with special relativity. Karazani clearly shows there's a mathematical mistake in it. But if they were to come at me and I said, yeah, I've looked at it and right here in line 4, they don't do that. What they ended up doing, and so that's what I said. And so I said, thousands of years of history show that mainstream anything never listens, which is true. First time I met Karazani in 1992, I went to the Long Beach Library and checked out every book on the history of science I could. Read Thomas Kuhn and the history of the paradigm shifts, and I found out one simple fact: mainstream doesn't change. It changes when they die. So, that's what he's trying. Okay, anyways, keep going here. Mainstream anything never listens, never do. Okay, thousands of years of history show that mainstream anything that, mainstream anything, meaning not just science, never listens, never debates, and never changes to the new paradigm shift themselves. You never get a scientist, oh yeah, I've been working in a neutrino detector for 35 years, but I admit there are no neutrinos. All we're detecting are false hits, which is what's happening. Says, I will seriously debate anyone. But mainstream is only interested in repeating their stance, ignoring our criticisms, and simply trying to save us from ourselves. And he says, but I'm a mainstream scientist. I've always been very critical of accepting claims in learning physics, but I still take issue with a lot of what you say. That's a euphemism. I've heard these things before, because they're coming in with here's, and I'm sorry, right from wrong, okay? But this is my take on this. I'm going to be brutally honest. People come in, and when they are nice about something like this, what they're trying to do is, here's what it is. I've got friends looking over my shoulder. Oh, Dave, he's got, over 1,000 subscribers now. He's subscribers are growing. People seem to like him. You look, most of his videos, they're almost all thumbs up, a couple of thumbs down here and there. A couple of them, there's a little more controversy, sure. But I'm going to go in there and I'm going to save everybody. But I'm going to be really nice. And I'm going to see him. He's going to get really nasty. I'm not getting nasty. I'm just telling him no, I applaud him for coming into the lion's den, but let's look at what he says. So he's already saying, I've been claims, but I still take issue with a lot of what you say. I mean, that's I'm a linguist. I try to get computers to understand language, right? What this guy is, the way he's saying it is on purpose. It's sort of the Griceum maximus discourse. That is, when you talk to people, you give them a sense of where you're, the feeling that you're trying to come across. He's using all of these peaceful kinds of phrases for things instead of these just basically hard-hitting phrases. So he says, one of my professors actually used to have people who email. Oh, this is the great one. This is so. One of my professors actually used to have people who emailed him. Used to. They stopped. I don't get that. Used to have people emailed him with some out there theories. They have theories in to have chats. So there's definitely not all of us. So it's definitely not all of us. I don't think they're having chats. So I put in here. I think I'm as me here too. Here we go. I'm pretty sure you are either not a mainstream scientist, maybe he's pretending to be, I don't know, or you are, or if you are here to save me and others. Everyone, that's what he's talking about. Everyone over the 25 years who have claimed to be mainstream scientists violate the debate rules, and it becomes a teaching session of what mainstream says. That's why he said something about math, didn't he? I thought he did. Well, maybe it's further on. Okay, anyways. I thought he said something about math, right or wrong. Blah, blah, blah. I believe you have taken it upon yourself to bring us back to the promised land. That's what I said. Oh, right from wrong. Right from wrong. As for relativity, both general and special are wrong. For one specific refutation of special relativity, see aerodynamics. It was checked by various physicists in 1994, and they could not find problems with his arguments for errors in special relativity. Also, I have a bachelor's in science and math. There was some place that he did talk about math, or maybe it was above this. Or maybe I'm hallucinating. Could be. Okay. All right, here we go. I'm open-minded, so I'll check out the resources. If you like to pick a specific claim, I have a discussion about it, and I'd be happy. I'm open-minded, but I side with the mainstream argument. When I say I'm a mainstream scientist, I don't mean in the sense I'm a famous or something. See, fame, always important to people in the mainstream. Fame, because famous means you're smarter. Famous means you know more. Famous means that your words are carry more weight than others. I'm just heading into my PhD program. I happen to be specialized in GR since I'm going into grad school for cosmology. And I said to myself, as I said, I myself take issue with a lot of claims. So I've done a lot of checking on things that you seem hard to believe. Okay, I'd like to discuss one of those things, and I am open to alternatives, but are you also open to the possibility mainstream science can be right? I've been looking at it for 25 years, and there are things in mainstream science that are right, absolutely. Most of particle physics is wrong. General relativity is wrong. I would point him immediately to the NASA scientist who says basically we don't get bending in an open space because of space-time. We only get bending in coronas of suns, just like you have water and you stick a stick into it and it bends. When you put light in the corona of the sun during an eclipse, yeah, the star's in a different place. Why? Because it's going through the corona. It'd be like looking through water. Did you ever notice when you look at through water, everything looks more collapsed? And you try to reach it, it's not there. It's like really far away. Well, guess what? That's what's happening in coronas of suns. But when you get outside, he said he couldn't find bending in general relativity. Why do what's? Tell me about that. You can explain to me all day long how you use it in cosmology. I know how they use it, but they're using the bending of light because it's going through something in space. This is a simple point. So, absolutely. So, I don't know. Maybe this is PhD project. I'm going to bring dissident science back to the fold. So, Prashant Shoma, he keeps, who's responsible for all this. Have you thought about rebuilding the Audenics organization? Well, once I know about the real status of Karazani, I can tell you about Lucy Hay. I'll tell you about that part of it. But the way I look at it, we should just continue championing his work. He's got really great work. He is very inspirational. So, we're coming up into a 90 minutes. Anyways, I got finally to the point that I wanted to talk about. Right from wrong, I'll think about it. The only thing that bothers me when I read this, it says, I myself take issue with a lot of the claims, so I've done a lot of checking on things that seem hard to believe. But I'd like to discuss one of those things. Here's my feeling about this. Right from wrong, I don't know if you're going to listen to this or you're going to watch this, or even if you're here, probably not. Maybe you would be under the list. But I just don't truly think that's what's going to happen. I mean, you obviously are saying, here's one of the things. Margaret Wortham, who wrote this book, I've told this story many times. I'm sorry repeating myself for those who are new. But Margaret Wortham, who wrote the book Physics on the Fringe, said that our problem in physics isn't that physics is wrong and our theories are all complicated and are wrong. It's because we can't explain them well. So what this guy, right from wrong, with this guy or gal, they're interested in saying, I know, Dave, they're hard to believe, but let me try to explain them. It's not, he says, I'm open-minded, but he's not saying, oh, well, tell me why you think it's wrong. We'll have a debate. What the proper debate is to put up, here's the way debate works. General relativity is wrong. That's what I'll say. Oh, general relativity is right. That's what he'll say. So if we were in a debate class, he would get up And he would tell and put all the list down of all the things or reasons why he thinks general relativity is correct. I would get up and then make my argument about what general relativity, why I think it's wrong. And then either I or him, I could continue then for the second part, and I would go through his arguments and try to show that his arguments are wrong or don't have support, that they're not good arguments. Then once I was done, he would go through my arguments and say to himself, David, the NASA scientist who spent all his life looking, I think it's laser work and astronomy or whatever. Every time when he was looking at the stars and they were supposed to bend, his glasses were tilted and like this, and so he saw the stars in the wrong place, but they were really. I mean, he'd have to come up with some explanation for that. You just have to say he's lying. And so, but regardless, what's going to happen is I would talk with him and he would listen. And he goes, oh, that's your objection? Oh, no, it's not. It's not the objection of what I think the problem with me. It's not the objection. Well, there's two objections. It's not the objection that general relativity could explain, for instance, certain things like gravity, the way sort of the orbits and stuff could work. But I would have problems with saying like it's bending space-time. Space-time is nothing. It's a bad idea. It's got to have a physicality because you can't bend nothing. So what is it? And if he starts telling me about what mainstream says, and he goes, I know it's hard to believe. So what he's going to do is he's going to spend his time trying to explain to me, just like Margaret Wortham, David, there's a guy here. She was at a book play, when this book came out in 1994, was it? No, 2012. Boy, am I so... That was like... that was off. 2012. And she goes, well, there is a guy who here is from the NPA, the CMPS, and those people they're working on, they love science. It's just that we can't explain it's really complicated. And because they love it so much and they can't understand the universe, that they go and they play with they're like kids and sit on the floor and they build their little models, and all the models are really simple, but they're too simple. That's not the way the universe is complicated and paradoxical. The universe isn't anything like that. So what he's saying is, look, I know it's hard to believe, but here's why you should believe it. But he will not go, he'll say, okay, address the NASA scientist who doesn't see starlight bend when it's outside the corona and sees it in the corona and then makes the conclusion it's the corona, not space-time. Explain that. He won't. He won't. He'll say, no, that's not true. Well, I doubt that he's done that experiment, if he has done it at all. And all the explanations they have where they use it. Oh, we use it here, we use it here. Yes, you do. There's mass there. There's corona there. There's stuff in space. There's space gas. There's space dust. There's all kinds of stuff. Yeah. Around every big object in the universe, there's stuff around it. It's really hard to find any planet with no atmosphere or nothing around it. Dust, I don't know. It's really hard. Especially when they're dealing with suns. So... let's see here. There's no more matter or less matter between two objects. That is, by matter you mean by explaining that. That's the particles are just energy waves required. Write a book on it, write a paper on it, do something. Explain yourself, it convince me. I can be convinced. So that's a difference. You don't see right from wrong saying, Dave, I could be convinced that general relativity is wrong. You think he's getting his PhD? It says, what is he saying? What is he saying now? He said, What is it? I was checked by. Sorry. He's saying he's getting his PhD, right? Specific team member this is what I was mainstream science. I'm just heading. Oh yeah, I'm just heading into my PhD program, and I happen to specialize in JR. Here's what you got. Hey Dave, I want to have a debate because, you may convince me that JR's wrong. He's not even offering that. It's funny. I'm here talking with Sal Nation. Explain to me how you're right, but don't explain to me in lots of words and stuff. I want to know sort of concrete things about it. I don't want to know about a system of things, how you sort of think it works. I want to know, what is it made of? Is it a lattice? How big is it? What's it made out of? When we write our book, that's what we do. We have diagrams of every particle. We tell you how. Look, right there. We tell you even why does light not make it through a solid object? Well, if gravity's making it through, why doesn't light? Well, light are waves, and by the time it like gravity, just imagine a bunch of suns arranged in a lattice structure, sort of like atoms. If you shoot a bunch of things that are waves coming, they end up being no waves at all. The wave structure sort of goes away and it becomes random. But that's just our explanation. But I am totally open to have somebody come up to me with their ether and say, Jeff Yee is right. Convince me. It's a good model. You won't hear me say, let me explain to you why you must accept the particle model when I don't even accept it myself. I think it's a great model, and I'm working on it. But so that was one of the other reasons. Turtles all the way up, turtles all the way down. I'm attracted differently to different things, but at different perspectives of the universe, which are required to define something in the upside down. Okay, well, I've got 10 people still here. Do you have any more questions? Was there something I wanted to show you? I don't think so. I do have the science. The science woke. It's coming quite well. Working a lot on that. So really good. I'm trying to put together all the missing pieces. We have lots of missing pieces still. I think one of the harder parts is doing the. I had to update the. I wrote special code for this PHP theme, and then it started to break and everything. But see if I can move this out. I'm going to squish myself. Come on, pop out. There you go. I'll squish myself. That's fine. There you go. But we've got this problems in science I've been working on a lot. This is where a person can go through and say, what? There's problems with these things? Black holes, plate tectonics, Big Bang, relativity, math, quantum mechanics, dark matter, particle physics? No. I was working on particle physics, give you a sneak peek. So a person comes in here, there's things wrong with this, and talk about Alexander Unsker, and it said, mind blown. Many critical thinkers believe that most of particle physics should be thrown out. Others propose new models to greatly simplify it. And I talk a little bit about it. And then I have Alexander Unsker, Unsker's War on Particle Physics. I just am writing this. You can say being edited. These are for the editors who are working on this stuff. The Delusion of Particle Fever. This is Harry Ricker. Man, he is a great writer. You notice it says read more, and I put this is so cute, become more woke. So you click on that. But I've been working on that. So we have, the problems in science. So I'm working on all of those. Some of them just don't have a lot in them. So, the Big Bang, I think quantum mechanics may not have anything. Yep, done. So, anyways, that's what I'm saying. I got to put something in there yet. Scientists, adding more people. Added Stephen Crothers to the scientists here. Where are you, Stephen? Right there. In progress. I just got to him, got some stuff from him, so I'm putting that in there. He's one of the great guys who, in the fights, we say, start here, fighting big science. He's one of those people. And here are some of his videos. And he's kicked out of the University of South Wales because he wanted to go against black hole physics. I need to go in there and edit this. Is this done or not? But anyways, the idea is you come in here, you start here, you can click on start here, and we tell you about how to become science woke. You consider yourself woke, your eyes wide open. You're not letting anyone fool you anymore. And you realize you can't believe everything you read or hear from the media. But did you ever wonder whether all those crazy articles about dark matter, 11 dimensions, multidimensions, and quarks are in fact, and gluons may in fact, ne'er we say, be the product of theoreticians gone wrong? Becoming science woke. Pretty cool. Put a few examples here and then start you out with. So the whole thing is start you out and then talk about what science woke means, critical thinkers, that kind of stuff. And then, there's problems in science. What are you talking about? There's no problems in science. You go in here and click on it. Black holes. Of course there's black holes. We know all about them. Of course, Stephen Hawking said there aren't. Well, Stephen Carruthers' War on Black Holes, kicked out of the universe. That's him again. A supermassive black holes, more fiction than science facts. This is by Harry Ricker. Great article. We can talk about that. Black holes, as described by big science, are very problematic. And that's for sure. So, that's the idea. So if you've never heard of this, like, oh my gosh, science could be wrong. Well, that's what this is going to. Again, this is being edited. This is for myself. I put all these in programming things in to say, I'm not done yet. And so, so they can click on all these things on any of these topics and find out what may be wrong. And we'll keep writing new articles about it. Then they can find out the new scientists that we have here and who they are. This is Dr. Cynthia Whitney, a female PhD student from MIT in physics and relativity, who now is a critic of relativity. What? Talk to that guy. Here's Dr. James Massel, expansionism. Dr. Halton Arp. Oh, where's this book? Oh, man. I had this book and I was looking at it. What did I do with it? Did I just set it down somewhere? Oh, shoot. I was looking for the Karazani letter. Oh, it's right in front of me. Right here. This is great. Did you know that Halton Arp talked about expansion tectonics? Can't believe it. I didn't know that. I found out from his book. I bought this book for cheap. Seeing red. Reading about it. It's so sad the way they, it's really, really, really sad how he, the whole, how he's picked on just because he was. Oh, I'll find it. I'll find it again. Mass creation, quantum mechanics. Yeah. I'm sorry. I was reading it today, and I was going through and say, "Whoa!" Oh, here we go. Ejection of new matter. It's accelerating ejection. I know I want to find it. Background radiation, empirical model, origins, dynamic, origin of companion galaxies, mass creation, quantum mechanics. Oh, I didn't find it. Anyways, it is here in this book. It's a great book. You should get it. It's a lot of stuff about galaxies in particular, but in the beginning and the end, he talks about his struggles and all that stuff. So he's there in it too. So I put him there. Junkin Shaw. Here's the guy. 30 patents in GPS. It says right there, 30 plus patents in GPS. And it says GPS reveals problems in special relativity. What? Can't be that. There's one of the great scientists, in my opinion. Replaces the Big Bang with an infinite universe. There's Dr. Joe Part, fourth part, and then this guy, super brilliant guy, Jeff Yee, Ernal Deneau. There's Laurie Gardy, Bobby Hilster. Oh, I got a picture wrong. See, that's why it's like there. Oh, I'm way at the end. Stephen Hurl, Neil Adams, comic book artist. What are you talking about? So, pretty cool. So you go through those, and then you can find new theories. We put them in Jeff Yee, ether theory. He's ether and Newtonian. We have universal cycle theory, force theory, particle model theory. There's autodynamics, rudimentary ether theory. That's Yarnell Deneau for the Deneau effect, which is going to go down in history, in my opinion. And fractals and black holes. He talks about that, and he talks about prime matter particles. I think he actually has a website. I got to find that out. But I got to put all this information. Anybody want to help? And we have our editorial staff, and this is pretty cool because you get to see Harry Ricker. I'm their chief. Who cares? It's just because somebody has to do it. Harry Ricker, he says, worked at Johns Hopkins and living in Columbia, Maryland. Harry studied creative writing at the local community college. And he initiated a lifetime. So he's got dozens of great. And he says, Dave, I'd be happy to put him on here. So he is cantankerous. I love him. Boy, he won't let anything go by. He has no qualms about anything. So, anyways, that's what we're at. I'm hoping to get people science woke. So if you haven't heard of me, you haven't heard of anybody, you should be able to come to the site and be able to. I'm showing you. I'm looking at it, and you can't see it, can you? I'm sorry. There we go. I'm looking at all these things. Anyways, yeah, there it is about the story. There he is. Harry, a great guy, and he talks about it. He also shifted electromagnetic theory was inspired by Ivor Cat. I got to put him in there. He'll be added. We'll put him in later. Theory of relativity, which was resulting in his disowning that theory as false and misleading. This began a lifelong period of study in which culminated a new approach to that theory, which eliminates its contradictions, paradoxes, and absurd conclusions. But he's a great writer. And then, of course, there's Laurie Gardy. She's what I call a staff writer, and she's learning to write. She writes pretty well. So, anyways, that's cool. Have you read Harn's? No, I haven't. Have you read Where Physics Went Wrong? Maybe. Let me see. Where Physics Went Wrong. I have another book place over there, and I should stuff them all over here so when I need to work. No, I've not read that. Oh, wait a minute. I remember the cover. Ooh, Kindle's only. No, I have not. Let's see. This book points out where physics went wrong since Einstein's formulation of the theory of general relativity a century ago. It points out inconsistencies and fallacies with the standard model and Big Bang inflationary. Who's it by again? Bernard. Let's see what other books he's written. Oh, I'm sorry. I'm not showing you this again. New perspective on relativity. No. I know most everybody. I wonder if he's in our database. Let me go see. Jeez. Buy a new book and. All right. Let's see. Database would be Levenda. Wonder if we have him in our database. db.naturalphilosophy.org. Go into find. Some of this isn't working. Hello. Database of almost 3,000. Nope, we don't have them in there. Shame on us. Shame, shame, shame. You guys come up with good stuff. Another person. I wish there was more info on John Chappelle on the internet. Yeah. Well, find a... Oh, wait a minute. Someone wrote something. Yeah. I think we have it on ours, though. I think someone wrote about him when he died. I thought I saw something somewhere else, but I think I put it on here. think I included it in. Yeah, that's a pretty good one. I mean, if you go to our database, you know, it's got this there. I can move this over. And this is the part that I saw. But yeah, I will tell you, I knew him personally, not for a long time. He needed a room to stay. One thing, he was not destitute, but he was not didn't have a lot of money. And in 1996, you know, I've always had a job in computer science and research, so you know, my salary's been decent. So you know, I flew out there on my own, and yeah, I had my own room and stuff. And he says, hey, he was shacking up with somebody in the sense of bunking with them, bunking with them, and he said, "Oh, that person's leaving. Could..." And I never met him before. It's the first time I was even at the MPA. It's in 1996 in Flagstaff, Arizona, and the guy says, "Hey, can I share a room?" And I said, "Yeah, of course. I got 2 beds in my room. There's no big deal. You can." And then he started talking about stuff, and he was eccentric at least you can say about him. He used to tell me, I didn't understand why the FBI was following me. I thought, oh boy, maybe he's delusional or something. He wasn't delusional. The FBI was following him. He said he used to go, because he lived in San Luis Obispo, and at the time it was President Reagan was at the time in the 80s, and he was telling me about the 80s because this was in the 90s. And he said, yeah, I don't know what the problem was. I mean, I was just looking in on into his compound, like this big compound area, while he was president, or maybe governor, I don't know, with binoculars. And I'm thinking to myself, well, of course we know that. Maybe he thought that was cool. I don't know. But he would talk about it. He would organize debates between mainstream people and people in his, you know, in the NPA. And he would get them together, and he didn't care if there were like 5 or 3 people. We have a video on our website. If you go to John Chappelle, you go there. There's a video of him. You know, I've got other videos too. I wonder if these. I'm supposed to digitize some videos. I wonder if any of these. Look at this. Oh, this is 2000. Got videos from 2000, the MPA. You may be in there. Yeah, I should digitize these. Oh my gosh. These are all 2000. If all this turns out to be like, it's not right, but at least we're doing science a favor, and this organization really is doing good things for the universe. It's like, I've got all this stuff. You know who has got more stuff than me is Greg Volk. That guy has an immense amount of stuff. We're trying to find a millionaire or a billionaire. Hey, anybody. I'm going to make a video. It's like, we need a millionaire who is willing to put some money in this direction so we can do some great things. You know? Get this word out, make better productions, that kind of stuff. I have a Patreon put together for that, but Hans Elfendave, I don't know. Hans Alfen. Ooh, Nobel Prize winner. Electrical engineer. I like him already. Where's he from? Sweden. He's from Sweden. There we go. He's described the class emission waves known as Alphen waves. He didn't name it after himself because people do that for you normally. Research plasma. Oh, okay. So there's plasma physics, charged particle beams, Cool. Particle accelerators. Personal life, no. Okay. Hans Alphen Prize. The Hans Alphen Prize awarded annually by European students outstanding contributions to plasma physics. Okay. Is he a Nobel Prize winner? Is that right? 1970 Nobel Prize in physics. I don't want to. With his work in magnetohydrodynamics. Oh, okay. It is the study of the magnetic properties and behavior of electrical conducting fluids. Oh, interesting. Very interesting. The effect of magnetic field. Oh, yeah, that's cool. Nice. My dad's an electrical engineer. In fact, our model describes really well electrical components, what's really going on inside. And actually, it turns out that's pretty funny that a lot of the movement of particles, or you want to call work energy, the potential work that's going in the movement, is outside the circuit. It's not all inside. Like a resistor, that's batteries. Batteries, I told you that have a field around them. So the energy in a battery isn't all inside the battery. Some of it's flowing around. Really cool. All right, guys. No more questions. I guess then I will wrap it up. It's, my goodness, longer than the people won't watch this, but no, I'm kidding. Anyways, I want to thank everybody. I do want to thank Right or Wrong, or Right and Wrong, or Right, whatever the guy's name is. I'm not sure. I'm not sure I'm going to take you up on it, because it sounds like, first of all, you're going to try to say, okay, you're going to tell me about general relativity, and some of it's hard. What's some of your objections? And I want to correct some of those objections. He's not going to be interested in debate. He's not going to be interested. Says, okay, on my side now, I want you to explain why we don't see starlight bending outside of coronas. So I don't see much use for it. I'm sorry about that, but I just don't. And I appreciate everybody's, Hollow Earth, could it be? Could be. Electric Universe, are doing great work still. Absolutely. Where physics went wrong, I'm going to check that out for sure. And I hope you'll have Greg interview. Yeah, I've tried to talk with Greg. He's, I think, busy doing other things. I don't know, maybe he didn't feel that what we were talking about was that worth it. But I can bug him again. He's got just tons of stuff. So, alrighty, folks, you guys take care. Also started known as the Donoplasmic Dissidents. Oh, Alphen, he did? Let me see. I want to look at that. Thanks. Sorry. Big. Alphen believed the problem with the Big Bang was that astrophysicists tried to extrapolate the origin of the universe from mathematical theories developed on the blackboard rather than started from known observational phenomena. He also considered the Big Bang a myth devised to explain creation. Very interesting. Wow. Very good. And he won the Nobel Prize. Very good. Thank you, Adam Lohr. Oh, nice. Very like it. Plasma. That's a tough one. Not sure what our particle model says about that. Very good. Learning from you guys. Again, my objective here is to give you a point of view that I've learned from over almost 30 years hanging out with, in my opinion, some of the best damn minds in the human race and science in the last 20 to 30 years. If anybody can find anything out about Karazani, that would be great. But because I haven't found anything. And, make sure you guys don't get married. Keep the engineering attitude. There's nothing that's 100% right. All we can continually do is look for better and better models, better and better explanations. Don't get yourself married. Don't try to over apply things everywhere. I believe this, and then now I can explain everything with it. Be careful. That's what ether people have problems. It's a light thing, and now they try to apply it to gravity. You're gonna have problems with that. So just stay open-minded, stay loosey-goosey, stay engineering attitude, remembering that we all have part of what we would call truth, even though there is none, and that anything that you believe can be completely debunked, and you can, if you're smart enough, if you find out you are wrong, you should be able to pull out of it and say, okay, I'm wrong, and go on. Most people can't do it because of the emotional side of human beings. But thank you so much. Stay critical. Stay thinking. I'm David Hilster, your science therapist, getting you to the promised land with science, being science woke. And yes, you saw the website tonight. So it's coming. It's coming. It's almost there. I just got to clone myself. Find a millionaire. You guys know a millionaire who wants to help move science forward? Have them get in contact. So take care, everybody. And thank you so much. And I appreciate all your comments and you guys coming here and subscribing, and let other people know. Take care.